Good morning, everyone. Today, what we are going to be looking at is special qualities of parallelograms. So, yesterday, when you guys were working with quadrilaterals, you learned all the different types and you learned some basic qualifications. So, for instance, you should know that in order for something to be a parallelogram, it needs opposite sides to be parallel to each other. So, two pairs of parallel opposite sides. Now, that means that both of these identical figures are parallelograms. But that's not all you can find out just by knowing that those opposite sides are parallel. And that's where parallelograms become very important, because if you can find more information given a small piece of information, it can really get you a lot farther in problems, and even if you guys are doing things like constructions later on. So let's start with angles. What does a parallelogram have true about its angles? Well, let's start with this. If you have consecutive angles, they are going to be supplementary. Now, remember that consecutive means in a row. So that's saying that angle A and angle D, which are consecutive, they're in a row, are going to be supplementary. So I could actually make a bunch of formulas, and we know that formulas are pretty handy. So I could say that the measure of angle A plus the measure of angle D is going to be equal to 180. And that's because it's a parallelogram. And we could keep going with all of them. D plus C is equal to 180, C plus B is equal to 180, B plus A is equal to 180. Now, what does that mean about opposite sides then? Well, or opposite angles then. Opposite angles are going to be congruent, which means that their angles are going to be equal in measure. So angle A is going to be equal to angle C in measure, and angle D is going to be equal to angle B in measure. So that is going to be the general pattern that you guys can use with angles, and we'll check out some problems that we can solve with that in a moment. But first, let's find out some more about the sides. When we're looking at the sides of a parallelogram, well, we know that they are parallel. However, we also know that opposite sides are going to be congruent. So let's go ahead and add that. And I can add that to the picture itself, because I know then that AD is congruent to BC and CD is congruent to AB. But that's not all. We actually can also find something out about the diagonals. So if I draw in my diagonals here, which is just connecting vertices that are not consecutive, and I connect these to each other, I end up with two diagonals. And these two diagonals have a special quality, and the special quality is that they bisect each other. So here, these get split into two even pieces, and then AC is going to, of course, get split into two equal pieces because they're going to meet at the midpoint. They're bisecting each other. And don't forget that that does not mean that these are equal to each other. So like B to, let's just call this point O. B to O and A to O are different lengths. You can physically see in this picture that they are different. But even if you can't see, you just have to remember that you can't assume that those two are going to be equal. It's only BO and DO. All right, so let's check out what we can solve with this with our problem below. In the parallelogram ABCD, if BD is equal to 11.6 meters and the angle ABC has a measure of 72, we want to find the other lengths, and we also want to find the other angle measures. So let's find as many as we can. Now, the first piece of information is absolutely crucial, and that is this is a parallelogram. If this were not a parallelogram, at this point, I would be able to make no conclusions, because all the rules that we learned above only work for parallelograms. So make sure that you double check it's a parallelogram before you continue. In fact, I recommend highlighting that if it's a test or a quiz so that you know for sure you can make the conclusions that you're making. Now let's then fill in the information that it gave us. BD, so B to D, is 11.6. And I'm just going to draw that in. I'm also going to keep in mind that if this whole thing is 11.6, this is going to be equal to this. I also know that ABC, this big angle, has a measure of 72. So let's figure out some different ones. I'm going to start with lengths. Let's say I want to know what is the length of DE. Well, the measure of DE is going to be half of BD. And I know that because BD is a diagonal, and diagonals bisect each other in parallelograms. So I can do 1/2 times my 11.6 to get my answer there, which is going to be 5.8. And of course, don't forget units. Now, I can't necessarily find out anything using the 11.6, but let's say I also wanted to know what the measure of AC is. While the 11.6 doesn't help with that, this 4.2 does, because 4.2 is the distance from A to E. And I know that A to C is going to be twice that long since the diagonals bisect each other. So I can take my AE, multiply that by 2, and I'll get myself the correct answer. So we're going to take 4.2 times 2, that gives us 8.4 meters, and that is the distance from A to C. All right, now it's time for the angles, and it turns out that we can find pretty much everything in here. So let's start with that. First off, if I wanted to find the angle CBE, if I know the whole angle is 72, that means that this section right here is going to be 72 minus the 41 that was provided. And that's going to give me an answer of 31 degrees. But that's not all. If I wanted to find the angle BCD, well, I know that these two angles, 72 and the whole of C, are going to be supplementary, which means I can do 180 equal to angle B plus angle C, or at least their measures. Since angle B is 72, I can then find my angle C by doing 180 minus 72, which is 108. Now, if I want to go a little bit more in detail and say, okay, then what is this angle, this BCE? Well, I can take 108 minus 63, and I'll have my answer. In fact, I can see that that's going to be an answer of 45. Don't forget that I can also find A and D very easily at this point, because B is going to be congruent to angle D, which means that if B is 72, the full angle D is also 72 degrees. And C and A are congruent to each other, so if C's entire measure is 108, then A's entire measure is 108 degrees as well. Notice that if you add these up, they should give you a total of 360 degrees, since we're still dealing with a quadrilateral. Now, could we find a few more lengths? Yes. Don't forget that the opposite sides are going to be equal in measure, so that means that DC is going to be 6.3 meters because its opposite side is 6.3. BC is going to be 8 meters, and that's because its opposite side is 8 meters. And there might even be some more things you can find out from there, but for now, I think that we've drawn over the picture quite enough. And we'll do one other example. So the last one that we're going to do is we're going to find the measure of each angle and side in the parallelogram JKLM. And that's what this symbol means. This means parallelogram. And that's just because we know mathematicians don't like to write things out, so if they can do shorthand for it, they will. And you may use that shorthand as well. Please try not to make it look like a rectangle. Keep it slightly slanted so we can tell it's a parallelogram. And don't forget, you do need every vertice mentioned in order for it to actually be the name of it. So JKLM. All right, now that we have that, let's fill in what we know. So the first thing that I can do is I can mark stuff with angles. So I know that angle M is going to be congruent to angle K. I know that angle J is going to be congruent to angle L. So I'm going to fill in those measures accordingly. Now, the next thing that I know about angles is that not only are opposite angles congruent, consecutive angles are supplementary. So that means that J and K, if I add them together, should equal 180. Woo, getting a little bit messy there. Sorry about that. So those need to equal 180. By the way, you can also find the sum of all angles and solve it that way. This is just like a slightly shorter version because you're dealing with less numbers. It will give you the same answer. So here I know that the measure of angle J is 7A, and I know that the measure of angle K is 13A. So 7A plus 13A gives me 20A. And 180 divided by 20 is going to give me 9. So that means that A is equal to 9. Of course, that is not actually the angle measure because A is just part of the measure. So what I can do is well, let's just list them together. Measure of angle J equals the measure of angle L, which equals 7A, which is 7 times 9, and we know that 7 times 9 is 63. And there I am running out of space. Don't forget the degree sign there. So I found my first set of angles. I can find my second set of angles now. We know that the measure of angle M equals the measure of angle K, which equals 13A, which is going to be 13 times 9. And 13 times 9 gives us a measure of 117. And that is, of course, degrees. Now we're up to our final step. I found all of my angles there. I just need to find my sides. So don't forget your markings. Since this is a parallelogram, it's told to us in the problem, I can mark opposite sides as equal. So in the end, I end up with a few equations. First off, I know that x is equal to 2y plus 1. I also know that 2x is equal to 5y minus 2. Now this brings us back all the way to algebra. What do you do when neither of these are currently solvable? Well, that means that what we have is what we call a system of equations. So what I can do is I can use what I know about x to substitute and solve. Since x is equal to 2y plus 1, I can substitute in that 2y plus 1 to get rid of one of the x's in my formula. That's going to give me 2 times, well, 2y plus 1 is equal to 5y minus 2. And the reason why this is so useful is it makes it so I have only y in my equation. Now I can distribute and solve. So this is going to give me 4y plus 2 is equal to 5y minus 2. Subtract 4y from both sides and you get 2 is equal to y minus 2. Add 2 to both sides and you end up with y is equal to 4. So I can substitute that in and solve. But first, let's also figure out what x is. Since I know that y equals 4, I can substitute it into either one of my equations and solve. So I've substituted into this one. X is equal to 2 times 4 plus 1. 2 times 4 is 8. 8 plus 1 is 9. Therefore, x equals 9. Now that I know these two things, I'll be able to find all of the sides, and let's just do this in as easy a way as possible. Substituting those in, I get 2 times x, 2 times 9 is 18, which means the opposite side is 18. Here, x is 9, and so the opposite side will be 9, and I would be finished. That is all. Check out the problems assigned on